Thanks so much, Yasmin. Great job. It's too bad the rules of the contest don't allow for videos because I've heard that there are some spectacular videos of those coordinated waves of contractions. So now, please join me in welcoming Darren Parker, a graduate student in Gene-Wei Li's lab. Darren was born and raised in a suburb outside Chicago. He did his undergrad at the University of Illinois Urbana-Champaign, where he was a biochemistry major and studied both nucleic acid enzymes as well as alternative splicing in liver and heart development. His favorite thing about biology is that from the same fundamental chemical and molecular building blocks come all of the incredibly diverse and varied forms of life that we see on Earth. Once, in undergrad, he says, a fly landed on the ice cream that he was eating, and he was so struck by the realization that he and the fly shared much of the same DNA, genes, and molecular machinery that he waited watching it for several minutes before shooing it away. Please give it up for Darren.
I didn't say minutes. So if there's one thing I've learned in grad school, it's that pretty much everyone in this room has a collective love for one thing: pie. I've been to the Pi Day quite a few times now, and I'm pretty sure I've seen every one of your faces there. Turns out, though, that the reason for this is not what you think. It's because as biologists, we are all just bakers at heart, working and striving to understand the ultimate pie recipe of nature, the cell. We're getting pretty close. We now know what a lot of the factors are, like ribosomes and tRNAs. We know what they do in the cell, and we know how much each of them are in the different cell pies. What we don't yet have a good understanding of, though, is whether or not the actual amounts of the ingredients or the ratios between them matter when building the ultimate recipe. So in this way, my graduate work is pretty simple. I'm like an inquisitive baker. I just want to know if changing the amounts of a specific ingredient has an effect on the overall product. Specifically, I study the tRNA synthetases in the bacterial recipe. They're an ideal protein family for this kind of study for three main reasons. First, they have a single, well-defined function in the cell. Second, I have a theoretical model that links their amount and the cell, or the pie's, growth rate, and I can test against this. And third, we have some really great measurement tools for testing the outcome of adding more or less. Bakers generally use their taste buds to measure changes in their recipe. Instead, I use ribosome profiling. What I've found is that, surprisingly, adding just a little bit less tRNA synthetase than normal leads to a much worse overall product. Reducing a single synthetase by less than half, as you can see, leads to a much slower growing pie. And with further reduction, the pie just stops baking entirely. And this is actually much worse than was predicted by my original model. What I found is that it turns out that what's most important to the cell is maintaining the ratios of those very conserved ingredients. And the cell will actively use less of those ingredients if the synthetase is limiting. And this leads to this effect of a much slower growing cell. On the flip side, I can add more synthetase than normal. And this actually also leads to a worse overall product. And what I've found is that molecularly, this is because it's basically just a waste of resources, making more than you actually need. So this work shows that nature has already built that winning recipe right there with 3 tablespoons of tRNA synthetase. And this is important to keep in mind as we continue to engineer cells to do new things. I'll end by saying that first, I hope I didn't make anyone in the audience too hungry, dreaming of this metaphorical, although very beautiful pie. And then also, the next time you're in the kitchen and you want to add more or less of your favorite ingredient, just think about how the cell might feel if you did so with your favorite gene. Thank you.